Welcome to lesson 29. This is the 9th lesson in section 2. By this stage in the program, you should be feeling very comfortable with mathematics. In section 1, we saw that mathematics is built on a 3-type structure. The equation processing component can be summarized by 3 words: shift and reverse. The following diagram gives a clear summary of the subject. All you have to do is extend the examples that have been offered. As you can see, the 3 types of maths are interrelated. The first is changing the appearance of something by using a standard process. Here, in the basic types, those standard processes are addition, subtraction, multiplication, and division. As it becomes more advanced, the process might be squaring or the square root. As you go through high school, you will find other processes that change a value. But what we are saying here is the value of 4 squared is the same as the value of 16, even though it appears different. So the emphasis on type 1 maths is the appearance. We are looking at having a value which is unchanged, but we can make it look different. Why would we do that? Because we're trying to establish a new emphasis. So this section is usually knowledge-based. You know how to change the appearance. The second type of maths is directed at finding a missing value. You are beginning with a statement which is incomplete. 2 times something is 10. By using a method of shifting and reversing the appropriate process, you can come to the conclusion that the missing number must be 5. In doing that, we introduce the notion of an inverse process. Here the 2 is multiplying the unknown, represented by x. Here the 2 is dividing the 10. Multiplication becomes division. They are inverse processes. In a more complex situation, 2 raised to a power is 16. So what we have to do is remove the influence of the raising to a power, and as you learn in high school, that process has an inverse called log, short for logarithm. Here we have the impact of a context. So we can say something has a total based on addition, something is being rescaled based on multiplication, or something is being compared to something else based on division. In all cases, in order to find the missing value, we isolate the letter in a series of steps which have a natural sequence, and we are working towards a goal at all times. That goal is getting the symbol representing the unknown by itself. The third type of maths is illustrating possibilities. We use a graph. It has 2 number lines. These represent the possible values that might be found in the situation. So here we've said if we double 5, we get 10. The related numbers from doubling, 5 and 10. In the image, 5 is associated with 10. And if we do this with a number of situations, we get a line or a curve. So we base this picture on sample possibilities. The decision a student has to make is which input values will they use. Well, the input values are chosen for convenience. The graph can be drawn by joining the points we have produced. The next diagram looks at three-type structure again. That offers a few new comments. You will notice it includes a comment about algebra. The underlying principle when applying algebra is that the appearance changes, but the underlying values you're working with don't. Now I'll make this diagram a little larger so you can see it more clearly. Yeah, you can see the three-column structure is maintained. Change the appearance, find the missing value, illustrate all possibilities. The first column, changing the appearance, is based on having good number skills, and they are developed in primary school. When we move into the algebra, where the representation is not as descriptive, it's based on using letters to represent unknown values. But the way we change the appearance of what we're dealing with has the same basis. What we are doing is focusing on the fact that when information's supplied, it includes a process. In the second column, finding the missing value, we describe this as having good equation solving skills. Our task is to rearrange a given statement so we can draw a new conclusion. The goal is to isolate a component so we give it emphasis, and the method is to shift numbers and reverse processes. This is usually covered in early secondary school. Later in secondary school, this is applied to practical situations. Each application generates its own terminology and symbols. The third type of maths is illustrating all possibilities. Now in this picture of the graph, it includes the possibility of having negative values. And the labels for the axes, cause and effect, start, finish, input, output, begin with, get a result. Each point positioned on this graph represents a pair of values. Those values are related because of the process that converts one into another. We use mathematics as a tool that allows us to understand and deal with practical applications. As that chart indicated, each application introduces its own terminology and its own symbols. Dealing with that terminology involves memory, but the processing steps are simply those mentioned under the heading equation skills. The next chart emphasises the importance of knowing that problems have a set structure. And it is analysis which exposes that structure and uses it to set up a successful calculation. This is what we learnt from section 2 of the program. Now this is the chart we had in the previous lesson. The problem can be any size, but it must mention 4 specific components. Those components can be hidden by the words describing the situation the problem is about. When you read it purposefully and analyse it, you will find 4 specific components. The keyword, the setting, the question, which specifies what is unknown, and the data, which allows us to generate a value for the unknown. The keyword and the setting work together. The keyword is a general term. The setting limits that to a specific situation. Between the two of them, they give us a formula to start our calculation. Once we have a formula, if we go back to the problem, we can find the question indicates which letter in that formula will not be replaced by a number. And the data should be sufficient to replace all the other letters and symbols. So our formula, which is all letters, becomes an equation containing 1 letter. We use our standard equation solving process which is shift numbers and reverse processes until you have an equation which contains 1 letter and 1 number. This sequence of steps is applied in all maths problem solving situations. There can be complications, but this is the basis. The most important part, the analysis, is usually not recorded. It should be, but usually isn't. The only insight into your thoughts is the content of the first line of the solution. If you begin with the correct formula, it is assumed that your analysis was correct. Now, I want to take a moment here to emphasize the importance of understanding what a formula is. A formula is an historical record of what people found when they investigated a particular set of circumstances. They have left a description of what can happen if you find yourself in those same circumstances. This allows us to build on their experience. So what appears on paper when you work on a maths problem is usually shown here in the box. All students should write the formula that describes what their processing is based on. Then they should clearly show how they're substituting the data supplied by the problem. And the final stage of the process is tidying up that statement to get a new conclusion. Now, students should show 1 line for each part of the processing. If there's 2 or 3 numbers to shift, you should only shift 1 at a time to ensure the overall processing remains accurate. So here we have 1 principle, get the remaining letter by itself. We have 1 method, shift a number and reverse its process. Because this is focusing on the numbers in this part, skilled use of numbers is essential. But the important part of the process is the analysis which leads to the beginning. If you begin with the correct formula, you should finish with the correct answer, because you understand the principle and you have mastered the method. What I want you to appreciate is the fact that mathematics is mainly occurring behind the scenes. When you look at somebody's solution on paper, what you are seeing is usually only the last stage. The most important part occurred before they put pen to paper. People who think that mathematics is about numbers are being distracted by the numerical values, when they should be looking for the words which guide them through the whole solution process. The following diagram gives another view of the overall process. Here we have a representation of what a student should put on paper for their solution. 3 steps: first, second, third. The first is a formula, the second is substitute, and in the third you just tidy up what you have written. Transpose numbers is the mathematical version, but tidy up is easy to follow. So we have a solution based on the first, second, and third step. The subject provides the formula. The question supplies the unknown and the data. And your experience supplies the ability to draw a conclusion. First step requires knowledge from what you've learnt in class. The second requires the ability to analyse a problem that is presented to you. And the third requires some skill working with numbers. The first can be a measure of your commitment to being successful. The second requires the ability to focus and concentrate on what has been presented. And the third can be improved from the point of view of speed and accuracy by practicing problem solving. So this is what a student should be setting out to put on paper as a record of their work on a maths problem. Students who pay attention to presentation and keep it complete are often more successful. When you learn about a mathematical topic, you are given a summary in the form of a rule or formula. Once this has happened, you're expected to remember that formula and use it as an entry point to any problem based on that relationship. If a problem description refers to anything which is outside what is normally taught in a class, it must make up for this by providing the appropriate formula. This makes the problem seem larger and more complicated than it really is. In fact, it is easier, because instead of having to remember the formula accurately, you simply use what has been provided. The person who builds a maths problem must include information about the size. Usually this information is in the form of numbers, and these numbers will have units which are derived from the context. As we have seen previously, it is also possible to use a relationship, such as the length is double the width. So if a number is supplied for the width, you can generate the appropriate number for the length. Students should get into the habit of including plenty of detail in their third step. To minimise the risk of errors, it's important that what a student sees in front of them provides feedback to guide an accurate calculation. An added benefit from a carefully laid out solution is that a person assessing the quality of that solution can see what was intended and still assign some credit despite an error. So there we have had a good summary of the progress we have made so far in this course. It gives us a solid basis to build on, and we'll keep doing that in the next lesson. See you then.